Okay, hello everybody. Welcome to the lesson. Today I'm going to talk about the solving problems for polygons. So in today's lesson, more attention will be solving problems rather than lecture. Okay, so let's get started. On the first question, we have a one regular pentagon. So what was the meaning of the regular? If all sides and interior measures are equal, these polygons are called regular polygons, right? So the polygon has five-sided. So how can you find each exterior measure of the polygon? If I'm going to extend the line here, all we need to do is take the ratio of 360 degrees over 5, right? Okay, so it's gonna be 72. So each exterior measure of the regular pentagon will be 72 degrees. Okay. And also we have one information about triangle DEF. It's equilateral. For equilateral triangle, their all sides are equal. Okay, so DE is equal to DF is equal to EF, and also it's a regular pentagon. Because of that reason, the length of ED is equal to the length of CD. Okay, so when you look at the triangle DFC, DF and DC, they are equal. So it's gonna be isosceles triangle, right? So for isosceles, the measure of F is equal to the measure of C. So let me call the measure of angle F and C X. Okay, so each interior measures will be 60 degrees for the equilateral triangles. Okay. So this is a straight angle. This is a straight angle. If this is a straight angle, what is the measure of this angle? Let me take y. So first, I will write 72 plus 60 degrees plus y is equal to straight angle, which is 180. So the angle y will be from here 48 degrees, right? Yeah, it's gonna be 48. So if it is 48 for the second triangle DFC, each interior measures, the sum of each interior measures will be 180 degrees. So we write 48 plus 2x is equal to 180 degrees, right? 2x is equal to 132 degrees. So from here we will get 4 6s 66 degrees. Okay, let's go to the next question. Okay, the interior measures are given here. It's a star question. 3x, 2x, x2x, and x. So all we need to do is define one triangle here. I'm going to use to solve the problem. I will take triangle NED. Okay, I'm going to take it. And we know that the sum of two interior measures will give us one remote exterior angle. Because of that reason, if I'm going to take the sum of 2x and 2x, it will give us the measure of angle E, which is 4x. And if we'll do the same thing for triangle DPL, x plus x will give us 2x. Okay. And the sum of interior angles will be 180 for a three-sided polygon, which is triangle. So the measure of angle N plus the measure of angle E plus the measure of angle D will be 180, right? Yeah. So respectively 3x plus 4x plus 2x, which is 180. So if I'm going to range left, we will get is a 9x, and on the right we have 180 degrees. 180 degrees divided by 9, it's gonna be 20, right? So okay, we got the value of x, which is 20 degrees. Glad to have it. For the example 3, we have a one quadrilateral, which is four-sided polygon, right? Okay, the sides are given: AD 5 root 3, AB 8, BC 6, and we will get here the area of ABCD. Okay, so for that reason, if I'm going to combine point A and point C, triangle ABC will be right triangle, so it's gonna be special triangle 8 6 10, or you can find the length of AC by the law of Pythagorean. And so how can I find the length of CD? By using the Pythagorean theorem. Okay, we have to apply it. So CD square plus AD square will give us the square of the hypotenuse, which is AC square. Okay. If we are going to put in the place of AD and AC 5 root 3 and 10 respectively, we will get for CD square is equal to 100 minus 75, which is 25. So we will get for CD is a 5 centimeter, right? Okay. We got this. It's gonna be 5 centimeter. To find the area of area ABCD, we have two triangles. So we say the area of ABCD will be the sum of area of triangle ABC and plus the area of triangle ACD. Okay. What is the area of triangle ABC? Base times height over 2, which is 8 times 6 over 2, plus for triangle ACD it will be 5 root 3 times 5 over 2, right? If we are going to simplify, the area of ABCD will be 24 plus 25 root 3 over 2 centimeter square, right? Okay. For example 4, we have one parallelogram and we have to find the shaded area. When you look at the shaded area, it is trapezoid, right? ABFE. Okay, and remember, how can you find the area of trapezoid? We will take the half of the sum of lower and upper base times altitude, right? Okay, so ABCD is a parallelogram. Opposite sides are same. If AD is a 5, BC is also 5 centimeter. We have a special triangle which is 3, 4, 5 here. Okay, and length CD is divided into 4 equal parts. They are all equal parts, so it's 3, 3, and 3. 3 times 4. The length of CD is 12. By the way, we are going to get for AB is also 12 centimeter. Okay. To find here the shaded area, which is trapezoid, okay, I'm going to take the sum of lower and upper base, which is 12 plus 3, right? And height, which is 4 over 2, so it will be 15 times 2 will be 30 centimeter square. Okay, we got this. The next question is going to be 5. We have a rectangle and the length of AB is equal to the length of AE. So if DE is X, the pairs of AB and CD, they will be equal opposite sides. It's gonna be X plus 1. If AB is X plus 1, AE is also X plus 1. So we can apply here the Pythagorean theorem for triangle AED, right? So for triangle AED, we will use here the Pythagorean theorem. And we know that the sum of square of the legs, which is X and 5, will give us the square of the hypotenuse, right? Which is X plus 1 square. Okay. On the left, which happens to be X squared plus 25, and on the right we will have X squared plus 2X plus 2. They cancels each other out. We can remove plus 1 to the left. It will be 24 and 2X. X will be 12 centimeter. But there is still work that needs to be done because we will get here the area of a rectangle. If X is 12, AB will be 13 centimeter. And to find here the area of ABCD, it will be 13 times 5, which is 65 centimeters square. Okay. For example 6, we have a square. All sides are equal, right? And the length of BF is 2 times greater than the length of CF. So if it is a K, BF will be 2K, right? Okay. So what is the length of AD? 3K, which is 6 it is. Okay. So here is actually I'm going to use another way instead of to use CF and FB. What is the area first? What is the area of triangle AFD? The base times height over 2, right? Okay. What is the base of the triangle? 6. What is the height of the triangle? AB, right? It's also 6. So the area of triangle AFD will be 18 centimeters square. Okay. I want you to look at the triangle AED and AEF. Let's compare the area of the triangles. These two triangles, they have common vertex and the common height, right? Because of that reason, their areas will be equal because their bases are same. ED is equal to EF. So if the area of AEF, let me take S, the area of AED is also S2, right? So what is the area of AEF? It's actually 2S. If I'm going to divide by 2, we will get 9 centimeters square, right? For just one S. The S is the area of the triangle AEF. So it will be directly 9 centimeters square. So this information, it was not necessary for us. Okay, without this also we can figure it out. Okay. For the second way, if we are going to apply here k and 2k, how can we find it? So it's 3k, it's gonna be 2 and 4, right? So the area of triangle ABF will be 4 times 4 over 2, which is 12. And here the area will be 6. 12 plus 6 will be 30, right? And the sum of the areas will be here as a 36 centimeters square. So we will get for the area ABF is 18 divided by 2. It's gonna be 9. Okay, but we don't need it actually. It's a very smart calculation. For example 7, we have a rhombus. We know that all sides are equal in rhombus. AD is equal to CD, BC, and AB. Okay, so if it is 70 degrees, triangle ADC is isosceles. AD is equal to CD, and we say the measure of angle C is equal to the measure of angle A, which is 70 degrees, right? Yes, it's gonna be 70. And the diagonals bisect the angles bisector. Okay, so, and also they are perpendicular to each other, diagonal BD and AC. 70 degrees, 90 degrees. So here the measures will be, we have two adjacent angles. It will be 10 and 10, right? Yeah. Okay. And for the rhombus, opposite angles are equal. So it's 20, it's also 20. The measure of ADC is a 40 degrees. So it's gonna be also 20 and 20, right? 20 degrees and 20 degrees. And the sum of interior measures of a triangle will be 180 degrees. Because of that reason, if I'm going to write the measure of angle BDF plus the measure of angle FBD is equal to 180 degrees minus the measure of angle BFD, right? Okay. A BDF here is 10 degrees, okay. The measure of angle FBD is 20, which is 180 minus the measure of angle BFD. So from here we will get for the measure of angle BFD is 150 degrees. Okay, it makes sense. For the last example, we have a kite and two pairs of sides are equal, so adjacent sides are equal here, which is AD and CD. And here is AB is equal to BC. Okay. So here is and we have two angle bisectors, angle D and angle B. So if it is 20, it's also will be 20 degrees. Adjacent angles, it's also 40 degrees. The measure of angle DAH will be here is 10, right? Because AT plus 10 degrees will give us one remote exterior, which is angle AHC 90. So first here we got the measure of angle DAH, right? Which is 10 degrees. Okay. So if it is 10 degrees, when we take the triangle DAB, the measure of angle D plus the measure of angle A plus the measure of angle B is equal to 180, right? So the measure of angle D here is 40 degrees. The measure of angle A, and let's say instead of question mark we can use the letter X. It will be 10 plus X. And the measure of angle B will be here as 20 degrees, which is 180. So from here we will get the value of X, 180 minus 40, 10, 50, 70, 110 degrees, right? Okay. It was the last question. Thank you for watching. Have a nice day.